So today we will solve some problem on ideal gas equation. The questions are mainly collected from the previous year question papers of IIT JEE mains and advanced. So without any wasting any time, we will be solving. So the first is, as I mentioned, ideal gas equation. So before jumping into problem, let us just recapitulate. PV equals to nRT, where P, V, N, R, T, all these five entities carry the usual signs as explained in textbook. So here, here we can see that uh, the first problem is which of the following volume, here it is said, and temperature plot, that is V versus T plot, represent the behavior of 1 mole of an ideal gas at atmospheric pressure. So what they are asking is, they have plotted V against T, and they have gotten some curves, and they are asking which one is the correct option. So let us try to establish the relation between V and T. So V equals to N by P R T, the way we are writing. As we know, a equation of a straight line can be written as y is equal to mx plus c, where c is the intercept, m is slope. So here it is, this one is y, this one, and this one is my x. Now from the given condition, where we can see that we have to measure y by x is equal to n by p RT. Now what is n by p? This n by p is, this n by p is n equals to 1 mole, and p is equal to atmospheric pressure. So it should come ideally 1 by 1 R, which is equal to 0.082, that is liter atmosphere mole inverse and Kelvin inverse. So this is what we should get. So we will try to find out this particular value from the given condition. So for A, y by x, that is, we'll try to measure the slope. Now this one is V1, this one is T1, and let us assume this is V2 and comma T2. So what we will do is, so delta V by delta T, so V1 minus V2 by T1 minus T2. For A, what happens, we'll measure this quantity in all of the options. So if we go for A, that comes around 38.8 minus 22.4 divided by 373 minus 273, that is 6.4 by 100 equals to 0.064. In case of B, it will be 28.6 minus 20.4 divided by 100 equals to 8.2 divided by 100, that is 0.082. In case of C, 30.6 minus 22.4 divided by 373 minus 273. Here also 373 minus 273 equals to, that will come nearly 8.2 divided by 100 equals to 0.082. Now, as we can see, this D option has negative slope, but from the given condition and from the ideal gas equation, R should be always positive, that the slope should be always positive. So we cannot accept this D option. So, and the correct options are, as we can see, C and B. So these both options are correct. Now we will go to the next problem. Before jumping into the next problem, we will follow some cardinal rules to solve the ideal gas equation. So before jumping into any problem, we will investigate if, here you can see, check the relation between N1 and NF, Ni and NF, and or establish relation between Pi and Pf. So what are Ni and NF? Suppose any event is happening. This is the initial stage of any event, then event happens, and that is the final stage. We will check. Suppose this is an event. Suppose event might be, what are the events? Might be expansion of gas or compression of gas or opening of two gas chambers connected uh, by a small tube, all this kind of event. So what we will check in all of the cases, we will check the initial number of gas molecules, pressure of the gas molecules initially, and after the event, initial final number of gas molecules and final pressure. These two might be equal, not equal. P final and P initial may be equal or may be not equal, but in any of the cases we will always focus on these particular two things. As I don't say that you cannot solve the problem in other ways, any solution, any way out which leads to the perfect answer is a good solution. But for in purpose for the exam strategy, I always suggest student to focus on number of moles initial and final, pressure initial and final, to solve the ideal gas equation. But you are always free to choose. This is our second problem. What does the second problem say? That two glass bulb A and B are connected by a small tube having a stopcock. Bulb A has a volume of 100 centimeter cube and contains a gas, while B is empty. So let us assume this is VB. So on opening the stopcock, when the gas goes from this one to this one, the pressure falls down to 40. The volume of the bulb must be, okay, they have given option. So initially what was there? Initial stage, the gas was in A volume A, and the pressure they didn't mention. So if this is a pressure given, initially the pressure was P, volume was 100 ml, 100 centimeter cube, and number of mole was N initial, that is equal to Na. What happens to final? Final pressure is point 0.4, volume is 100 plus VB and Ni equals to NF, because no gas escapes out. Whatever the gas was, this one in this one, and it goes into this 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 place. So we have gotten this one. So now we will see that Ni is equal to N final. So we will solve the equation in this manner. So initially that was, please ignore this one, I will use this space to make you understand this one. What was initially is equal to Na, that was P into volume was 100 centimeter cube by R is universal gas constant into temperature. Okay, this one was temperature, and they didn't say about any change of temperature. In the second case, what happens is final, what was there, final was, the P was 0.4, but the volume has increased, that is VP हो गया, and 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 R, and the temperature remains, same. So as we know, we will do this equation, Ni is equal to Nf. We will try P into 100 centimeter cube by R into T equals to 0.4 into 100 plus VB divided by RT. If we do this one is P, this one is P, sorry, I have take it from this one, P, and VB equals to, if we calculate this one, VB equals to 100, this is centimeter cube, this is also centimeter cube, 100 minus 100 by 0.4 minus that is, okay, so this will be if you calculate this one, this will come around 60 divided by 0.4, that is 150 ml. Please do the calculation. I have just done for this one. I wanted to avoid this one, and remember this is centimeter cube. So this is centimeter cube, this is centimeter cube. I have strike it out.